It's in one piece! Oh, except for the nose cone, but... Hello, Internet. What you just saw was the flight of this rocket right here, Grapefruit 3. So Grapefruit 3, if you don't know, is a thrust vector controlled rocket, or it's supposed to be. It hasn't quite worked yet. So, my first two rockets, Grapefruit 1 and Grapefruit 2, both didn't successfully thrust vector. If you don't know what thrust vectoring is, I'll explain it real quick. Thrust vector control is a way of actively controlling a rocket. It takes the position of the rocket and it puts it through multiple filters which help it decide how to correctly correct for any error from the desired flight path of your rocket. My rocket, it used gimbal thrust vector control, which is a 3D printed gimbal at the bottom of the rocket here, which moves the rocket engine back and forth so that it can change the position of the rocket. So that's just a really simple and brief explanation of thrust vector control. If you want to learn more about it, you can check out in the description. I've linked a technical report of Grapefruit 3, and inside I've linked other resources on thrust vector control. So if you want to learn more about thrust vector control or about this rocket, you should check out that link and read through the technical report. It'll have all kinds of cool stuff if you are interested in rockets. Back to this rocket, the one you just saw fly. So I've made quite a few improvements since Grapefruit 2. The most notable of them is in the software. The biggest thing that I've changed is previously on Grapefruit 1 and Grapefruit 2, in the software I was using a proportional controller to get from the raw angle of the rocket to the output of the rocket that it puts into the servo motors. Now I'm using a PID controller, which uses the proportional controller but also two other elements, the integral and the derivative. This allows for a much more accurate and better controlled system than just using a proportional controller, which should have helped stabilize the rocket. Now, also since the last rocket, I've redesigned my nose cone system. So now it's much bigger and it's a lot more streamlined. And also, it's using one of these big servo motors to pull it down. The rocket also now has two parachutes, which accounts for the extra mass. The rocket has a mass of about 500 grams, which is a lot more than the previous rocket. The design of the TVC mount is exactly the same. It was just reprinted since the last time in a stronger filament and with a more dense infill. And the biggest changes of them all to the hardware would be the flight computer. If you saw my stream about 4 months ago, you saw me assembling my first flight computer that I designed as a PCB. Here is the PCB that I designed, and well, it's not quite perfect. By that I mean it's actually garbage, it's terrible. I didn't do a very good job with it, but it was my first PCB I ever designed, so I'm kind of proud of it. But yeah, it's got a few issues. The first of the issues that I noted in the stream that I did a couple months back. The holes for the BMP are too small for the actual pins to fit inside. So I had to take little wires and cut them up and then solder those together to the BMP in order for it to connect to the pins. But there was another big problem with it. Somebody, I'm not going to mention any names, forgot to route a very important wire, and it might have been the 5-volt wire that connected the Bluetooth module, the BMP, and the IMU. Yeah, whoever did that, yeah. Oops. Editing Danny here. If you look at the schematic, you can see that the 5-volt wire is routed from the IMU to the BMP to the Bluetooth module, but it never connects to the TVC because I never routed that wire. Oops. Yeah, I'll get him next time. But I was able to easily fix this by routing just a normal wire across the board, and that fixed that problem. The next problem I ran into with this board was that I couldn't get the Bluetooth module to connect. I did everything I could think of, and I rerouted everything, I wired things directly. I tried for like a week and a half to get the Bluetooth module to connect, and it just wasn't working. So I ended up going with a more autonomous solution, and I just put a timer on the switch on the Rocket so that after 10 seconds the Rocket would go off on its own instead of letting me control it from my phone. So it's not the biggest deal, but I'm going to work on that, and I'm probably going to use a different Bluetooth chip on this next Rocket because I wasn't very happy with the one I used. So the igniter system stayed exactly the same as it did in the previous Rocket. I haven't changed anything about it, but unfortunately I did not have as much success as I had with the previous one. The launch that you saw at the beginning of the video was unfortunately not the first attempt at launching. It took me 4 launch attempts in order to actually launch the Rocket. The whole igniter system is really simple. There's just a 9-volt battery that passes through a relay, and then once the relay is triggered, it allows the 9 volts to go to the actual igniter that ignites the engine. It's super simple, and it doesn't really break. So the reason that it took 4 attempts in order to launch the Rocket was because of my batteries. I purchased these E-Circuit super heavy duty batteries, and I assumed that since they're advertised as 9-volt batteries, they'd be 9-volt batteries. So I went to the first launch attempt with the 9-volt battery in the Rocket, set it up, and hit the button, and unfortunately nothing happened. I assumed that the battery was dead because it had been sitting out for a little while. I had a slight break between the time that I finished building the Rocket and the time that I was able to go for the first launch attempt. So the Rocket had been sitting around for about 2-3 weeks. I thought maybe somehow the battery had drained slightly, and I had tested it a bunch of times, so I just assumed it was a slightly depleted battery and it wasn't enough to get the igniter going. So I replaced the battery inside of the Rocket, and I did that. I didn't want to take all the other stuff out, so I just made a little bit of a hole here in the Rocket and pulled out the battery and then swapped it out with the new one. And once again, I used the same brand of this battery. And so I went out for my second launch attempt and still couldn't get the igniters to go off. So came back, tried again with a fresh, brand new battery that I had just bought, and then put it in, went for a third launch attempt, and still the igniters wouldn't go off. So the fourth time I was a little bit confused because I could see that I was getting voltage to my igniter wires, but it just wasn't enough to set off the igniters. So I decided to get another one of these batteries, but before I put it into the Rocket, I decided to check the voltage on it. So I tested my brand new battery on my multimeter and found that it only read 8 volts, which is weird because the battery is advertised as 9 volts. So I decided to get a different brand of battery. I then tested an igniter first on one of these batteries and then next on my brand new other brand of battery, and the igniter didn't work on this battery, but it worked great on the new brand of battery. So whatever brand this is, E-Circuit, it's bad. Don't buy those batteries. They're not 9 volts. So now after we've talked about this Rocket, it's time to talk about Grapefruit 4. That's going to be my next Rocket in the Grapefruit series, and I'm gonna hopefully make some big improvements. One of the big things I want to do is make the battery system much more better, because currently it's a big pain to have to make a big hole in the Rocket in order to take out the battery and swap them out, and also that's just the battery that powers the igniter. The battery that powers the flight computer is actually not accessible unless I take the entire flight computer component out, which means I have to take out either the thrust vector control mount or the nose cone, which is a big pain because then I have to line everything back up. So in the future, on the next rocket, I would like to have one battery that powers both the igniter and the flight computer, and I want it to be easily rechargeable and accessible. So that's a goal, and I also want to work on improving my software. I believe that there's a lot more I can do to make it better. I also need to figure out what happened, so I'm going to check out the flight data and yeah, figure that out. So yeah, peace out. Woo.